I'm Joe Yoder.
I'm Paulo Merson.
And we're going to talk about some fundamental ideas. And we're going to move quickly, because as you see, we have definitely within 15 minutes, and we want to get through everything. And, you know, you can think about, a lot of you are very, very well aware of, like, SOLID for the O design from a long time ago. Bob Martin kind of brought these together. He didn't invent the ideas, but he did a good job of bringing them together into a nice acronym, like single responsibility, or Berkshire Myers open for extension but closed for modification, or the well-known Liskov substitution and interface segregation and dependency inversion principles. But what if we're dealing with microservices? So if we're designing services and microservices, is there something similar, kind of good design principles or good principles we need to think about when we're dealing with microservices?
So as a matter of fact, last year I was teaching microservices public course at the SEI, and one of the students asked me, so do the SOLID principles apply to microservices? And well, the answer is partially, but I gave it a lot of thought, and Joe and I have been talking about that. So, and then we came up with, well, what would be the core design principles when you're creating microservices? And of course, we had to come up with a kind of catchy acronym. We had SOLID was taken. We thought liquid, fluid didn't work.
It had to be a word.
Yeah, shield was taken. So
we came up with ideas originally. You might, if you saw what we had marketed, it had the ideas. But as we talked to more and more people over the past couple of months, and then even if you look at like Chris Richardson's webpage, loose coupling was key. So we decided we needed to kind of extend from the essential ideas to some good ideals that might even sound better. So let's go through these. And let's start off with interface segregation. And a lot of you know from the object world anyway, is it's really dealing with fat interfaces. And there's a kind of a counterexample you can look at. And really, you want to break up your interface. To me, interface segregation is almost like SRP to the interface. Let's do a good job of defining interfaces and not overload interfaces or have too many options that may or may not be used. You kind of have to have a balance with that. But what if we're dealing with microservices?
So for microservices, the notion of interface segregation is particularly important because oftentimes you create a back-end service that will cater to the needs of multiple types of clients, multiple front ends. You may have like a web front end, you may have different mobile applications, maybe some other services are calling your service. And in the old days of SOA, and I was there trying to use it and teaching it. There was this notion of creating a service that would offer a canonical model, would expose contracts with canonical schemas, and then all the clients around the kingdom should abide by that contract and use that contract. Well, that doesn't work anymore. So today we know each client needs to see the service using possibly through a different contract, a contract that is more suitable for the client's needs.
But how? How would you do that?
So if you're a fan of Harry Potter, you know who knows the answer. Best friends, BFFs.
Okay.
So backends for front ends, that's a design pattern, and it asks you to have that service with a standardized contract, and then each front-end team can configure things using an API gateway kind of infrastructure that will do message transformation, protocol translation, whatever is needed to make that service visible in the most suitable form for that different client.
So BFF is a form of an API gateway.
Exactly.
Okay. Well, D for deployability. And obviously, deployability was already an issue before. I mean, just getting everything together. But obviously, this goes up a lot when we're starting to deal with microservices, because even, at least before, we had things kind of somewhat controlled with how things were being deployed. But now we have many, many deployment units, and possibly a lot of different types of things we have to be worried about, and many different databases and everything else. So how can we deal with some of these types of issues?
So in the old days, you would create software dev. You would apply your design techniques, do the best with the implementation, the right patterns, clean code, everything, and then push to the repository, you're done. Well, not anymore. This is the microservices era. That's what we're talking about, DevOps. So the dev has to take care of deployability. It is their responsibility. So you need to make design decisions and employ several strategies, such as things we listed here: DevOps, log consolidation, containerization with container orchestration, blue-green deployment, canary releasing, using possibly serverless architectures, pipelines in continuous delivery fashion, distributed monitoring with high visibility, and
so automation and visibility are very key.
Yes,
principles
automation
and,
is a key
and
enabler
a lot of
for
stuff.
that.
Okay. Now, event-driven, obviously, synchronous requests are still everywhere, and we still have to be thinking about that. And you can look at this example if you can think of online reservation system. But
Yes.
for dealing with this is, how can we deal with some of these issues?
Yeah, so we're going to continue seeing synchronous service compositions, but today's scalability and throughput requirements have been asking for more asynchronous interaction across microservices. So instead of a synchronous-based design like this one, oftentimes, if you have a chance, you should try to create a design that looks more like this, in which case you have a service, it gets a request, and then it sends an event out to an event bus, right? And then so other services will subscribe and get that event, do some processing, possibly send out other events, and the overall transaction will be activated in an event-driven fashion. And there are several benefits. There are trade-offs involved, and but it's a thing that you strive for, create event-driven architectures.
So in general, for good design of microservices, favor event-driven over that. Now, how about availability over consistency?
So yes,
A is for availability.
Yeah, well, it has been mentioned, of course, in the conference already, the CAP theorem. In practice, it gives you two options. You need to choose availability or consistency.
I can't get both?
No. Well, if it's not Christmas, you can't. And the problem is, the good news is, in industry, people, practitioners, vendors, a lot of intelligent people have put a lot of effort to create mechanisms and technologies to allow us to choose availability over consistency. And why do we do that? Well, if you go online to buy something, you may on a web store, you buy something and then you get a message saying, hey, you get your request, your purchase order. Maybe minutes later or a day later, you get a message saying, oh, we are sorry, the information about stock was wrong, your purchase order was canceled, you got refunded, but yeah, that product was actually not available.
So this really models the real world a little bit better.
Yes, and it means users are used to that situation, so they can accept that. They tolerate this level of inconsistency. What they won't tolerate is going to their web store, and the web store is not up and running, it's not available, simply because they have chosen consistency. So choose, even if you don't have a sorting hat,
right.
Given the option, in general, for the benefit of your users, you should choose availability over consistency.
Okay. And then the L, with loose coupling, obviously loose coupling's been around since the beginning of time with good software architecture. Let's think about keeping things more lower coupled. But this can definitely have a big challenge for evolution and maintainability, especially with microservices. We can end up with, and this is actually a picture of a real example of a lot of microservices from a very successful system that I've been working on with some people. In the middle there, you might see pieces of the monolith still as part of that. But if things become tightly coupled, you can definitely still have all the issues we had before. And with microservices, that can really be magnified. So let's talk about maybe some things we can deal with loose coupling for microservices. Now, one thing that we were talking about earlier, which is model around the business domain, using things like DDD or any kind of other good domain modeling technique can help. But what are some other things, for example?
Well, you can use different patterns, like the facade, different patterns, wrapper patterns, event-driven architecture, hypermedia. There are different strategies for that.
Right, but you also think about the contract. So you want to carefully design the contract. You mentioned some of these wrapper patterns that are well-known design patterns, but there's also some other well-known patterns that apply to microservices a lot that can help, right? To keep things, separate the coupling. In fact, some of the event-driven was helping with some of that, as an example. And then finally is the S for our ideals. And the S is single responsibility principle. And obviously, when we think from the object-oriented principle, we didn't want a God object or an object that had too many roles. In this example, you can think of magazine subscriptions that handle both not only how to subscribe, but the status of the subscription, how to make payments, how to do promotions. That's starting to overload that. And it can have all kinds of potential consequences. And SRP, conceptually, most people understand right away, even from a method level, but it's one of the hardest things to get right. Because a lot of times you see people either making things too simplistic or trying to find those boundaries and stuff. So let's look at this for microservices.
So for microservices, this is critical. And since the beginning, people were trying to create microservices that were kind of the right size, not too small, not too big. Because if you create a microservice that is packed with too much functionality, responsibility, it is more of a microlith,
okay.
And then it will bear the pains of the monolith. Yeah. On the other hand, if you we create microservices that are too small to complete something big, you end up with several microservices that need to interact. In worst case scenario, you may have multiple microservices that change data, and then you may have the curse of distributed transactions.
Very chatted microservices, or yeah. So you want to keep away from this curse.
Yes,
right.
This is a bad curse. It's a killer curse.
Okay.
Well, good news is DDD can help with a single responsibility principle.
It's not a silver bullet. It's something that
beyond.
can help. Definitely look at our if you're interested, look at our previous talk. But also the principles of good domain thinking, of modeling around the domain, whether you use DDD. DDD has some core concepts that you can find useful for modeling your microservices, but it can help deal with a lot of these different types of ideals. So anyway,
for people out there creating microservices, designing or evaluating microservices designs, we believe that we need ideals.
Yes, we need good ideals, just like any. And the I is for interface segregation.
D is for deployability.
E is for event-driven.
A is for availability over consistency.
L is for loose coupling.
And S is for single responsibility.
Thank you very much.
Thank you.